This is a short video about cleaning the photometer cell on an API Teledyne 400e analyzer. This is only guidance. We'll go through the procedures in the manual and provide some additional information for you. To begin with, you're going to need a few things. The first thing on the list is a couple of spare photometer tube O-rings, and you can see that on the image on the right. Frequently those will seize to the glass tube and make it difficult to get or if not impossible to get the tube out, and sometimes you have to go in and destroy those in order to get the tube out. Another thing you'll need is a Phillips head screwdriver. You'll need some distilled water for cleaning. And I use Kim wipes or other lint-free delicate task wipes in this procedure. It's not specifically listed in the manual, but this is how we do it, so I'm going to include it here. Also, as a note, before you remove your analyzer from service to do any maintenance, you need to conduct your routine single point check. That locks in the last data that your analyzer was recording. In order to validate the data for the previous 2 weeks or whatever your check interval is. We always did our cleaning of the absorption tube at least during an annual maintenance, and the procedures for doing this and the timing of it are listed in the manual. If you live in a dirty environment where it may become more contaminated, or if you're having some instability, in your analyzer, you may want to do this more often, but you should at least do this annually. So the procedures are in the manual. In this manual, it's 11.3.6.1. And we'll go through all of these procedures and we'll list these numbers on the slides, on the following slides, so you don't really need to, I'm not going to read them here, but you will need to follow these procedures and understand what these procedures mean. Step 1 in the procedure is to remove the cover off the analyzer. You should turn the analyzer off, remove the cover carefully. There's some screws on the side that you pull out and lift it up. This image shows the front and the back down. You don't have to do that. You have plenty of room to do this procedure without doing that. And the second step in the procedure is to locate the optical bench. If you look at the gold covered rectangle that you see there, the box, that's the optical bench. And it's important to understand which side is which, because some of the procedures talk about sliding the tube in a certain direction. So the detector side is on the left as you're looking at this, toward the front of the analyzer, and the lamp side is on the right hand side. So there's a UV lamp. It sends a beam of light through the tube that you're going to clean, and then there's a detector on the other side that senses the intensity of the light. Step 3 in the procedure is to remove the top cover of the optical bench. There are 4 screws that hold it down. Remove the 4 screws and lift it straight up. Step 4 in the procedure is to unclip the sample thermistor from the tube. The thermistor measures the bench temperature, and you can see it on the right hand side of this. There's a metal clip, and the thermistor is attached right underneath the metal clip. Sometimes it helps to spread, pushing it off directly can be a little difficult sometimes, and it is a glass tube, so you need to be careful. So sometimes taking your thumbs on your 2 hands and spreading that metal clip out a little bit to make it release a little easier is useful. So here's a little closer image of the thermistor. And this slide shows the thermistor and the metal clip removed from the tube. In step 5, you remove the 2 retainers There's one retainer at each end of the tube, and there are two screws that hold that retainer in. So if you remove those two screws on each side, and the retainer will just slide back onto the glass tube. When you pull back the two retainers, notice that there's a flat side that goes against the housing, and there's a chamfered edge on the other side. You'll need to put those back in the same way that they came off. So look at the retainer and make sure you notice the flat edge and the chamfered edge. Again, the flat edge goes in toward the O-ring, toward the housing. After you remove the retainers, screws, and slide them back, then step 6 and step 7 talk about using both hands, carefully rotate and the tube to free it, and then slide the tube toward the lamp housing. And then it says the front of the tube can now be slid past the detector block and out of the instrument. So once again, the lamp housing in this picture is to the right. And if you look down, you can see the lamp, the silver lamp that sticks in, and I have it marked there as lamp. That's the lamp side, the lamp housing. And the other side is the detector side. The left side in this picture is the detector side. So ideally, you would just spin it, and it would be able to slide in toward the lamp housing a little bit, just enough to get it to clear on that left side, to clear the detector housing. And then you lift it up and just enough to slide it out from the lamp housing. So you push it in toward the lamp housing, get it just far enough in that you can raise it up out through the detector housing on the left side, and then slide it out of the lamp housing to remove the tube from the analyzer. One problem you're going to run into, which I've run into many times, is that sometimes those O-rings seize on the glass tube. And so you just can't get it to break free because the O-ring is seized to it. And when you twist it, the O-ring is seized to the glass tube and it twists inside the lamp housing, usually on the lamp housing side, but sometimes also on the detector side. And then it just doesn't come, it twists around, it feels like you're doing everything you should do, but it doesn't come out. So in that circumstance, you may have to get in there and tear out that O-ring. You can try holding it or breaking it off of the tube somehow, but usually that's why you have spare ones of those on hand when you do this procedure, because there is a fairly good chance one of those or both of those are going to seize to the glass tube, and you'll have to just carefully get in there and dig them out in order to remove the tube. So here on the right hand side you can see some residue on the tube. That's where the O-ring had seized to the tube. And so you'll have to clean that off, and I'll talk about that in another slide, but this just to show you that can seize in there, and then the tube just won't come out. So sometimes you'll have to go in there and destroy that in order to get the tube out, and the next slide will give you at least some indication of one way to do that. So sometimes when you're imagine the tube is still in with this, and then Kent's going in with a seal pick to kind of pick that tube out of there. But if the tube's still in there, you have to be careful with the glass tube because you don't want to break it. Sometimes you can go in with a seal pick like that and maybe have some help, and somebody try to hold the O-ring while you twist it to seize it off. Most often you're just going to have to tear that out. So some way, with some kind of small cutting tool or something that can tear that O-ring out of there. Again, with the glass tube on there, you have to be careful not to damage the tube. But there's a good chance that's going to seize onto your tube, and you're going to have to just rip that thing out of there in some way without damaging the tube or the lamp housing or the detector housing if you're going on the other side. Anyway, it takes a little, you don't have to be afraid of it. But you do have to be aware that there's a glass tube under there, and you don't want to scratch things up. You want to be careful. Carefully cut that thing out of there so you can get your glass tube out. So step 8 in the procedure talks about cleaning the tube once you get it out. First thing I usually do is look at it through, and I'll show this on another slide, but look at it and see how dirty it is inside. And then the procedure in the manual says clean the tube with deionized, and I put in distilled water only. So I just use distilled water. You can get it at a store. And it doesn't have minerals in it or any chemicals or anything. It's just distilled water. And then number 9 in the procedure says to air dry the tube. Now I do these things just a little bit differently, but essentially the same thing. I'm using only distilled water, and I'm using a plug, using a Chem Wipe plug to go back and forth to clean the inside of the tube. So to do this using a Chem Wipe or other type of delicate task wipe, lint-free delicate task wipe, I create a little ball and I saturate it with distilled water. Then I put it into one side of the tube. Using something that won't scratch the tube in order to push it through. In this case, I'm using a 1/8 inch Teflon tubing. Clean off the tubing on the outside, and you're just using that tubing to push that plug through. And it'll come out the other side, and then we push it back the other direction, and we do that several times. So the plug comes out the end. You go back the other direction, and if maybe get a clean plug and get it saturated with distilled water again, and maybe go through 2 or 3 new plugs, but get it good and clean going back and forth. And step number 10 in the manual says check the cleaning job. Now this is what I do before also, so I can see the difference. And looking down the bore of the tube, it should be free from dirt and lint. And what I look for, and usually I have to take this outside, and you want to be careful not to look directly into the sun, but I find I get a better image of what's going on the cleanliness of the tube if I'm outside and pointing it in a general direction of the sun so that it kind of shines light through it. I'm looking for a real shiny side. And the reason I like to look at it before and after is because then you can see the difference in the shininess. Now, I'm not just looking for dirt and lint. I am looking for that, but I'm also looking at the edges of the tube and looking at how clean and shiny that it looks. You got to kind of move it around. There's a little feel for it, but you'll see what I mean when you do that. Step number 11 in the manual is to inspect the O-rings that seal the ends of the optical tube. So sometimes those O-rings will slide off with the tube when you pull it out, and sometimes they'll stay in the housing. But if there's any damage to those, you replace them. And again, these are on the outside, they'll seize. That's common. I've run into that several times to the glass tube. So when you have that, you go in and scrape those off with a thumbnail or something soft. You don't want to scratch the glass up, but you want to get that stuff off of there. And if the O-rings are good, you can reuse them if you didn't have to tear them up. If they're not good, replace them. You may want to, just as a routine, they aren't that expensive. You may just want to routinely replace them every time you do this procedure. But in any event, again, I'll remind you, you do want to have at least 2 of those on hand when you do this procedure, because there is a chance you're going to have to really tear them up to get that tube out of there. Step 12 in the procedure simply says reassemble the tube into the lamp housing and perform an auto leak check. Basically, they're saying put things back together. Remember when you're doing this that you have to have that flat end of the retainer facing the housings. The chamfered end goes inside toward the center of the tube. And make sure the O-rings are in place. And we'll go into a little bit more about some of this in the upcoming slides. To reinsert the tube, you're going to go backwards from what you did initially. So you have to make sure you have your retainer rings inside on the tube, the O-rings in there, and then you're going to slide it in toward the lamp manifold. The left side toward the detector manifold is going to be up above the detector manifold just slightly because the tube's too long if not. And then you inject it or insert it into the lamp manifold side and you push it forward just enough so that you can lower the tube on the detector side past the detector manifold and down toward the hole that it goes in. So this, again, you put it in just enough to get it down on the detector manifold side, just enough to clear that detector manifold. And then once you get it in, both sides are in, the manual talks about before retightening the retainer screws, gently push the tube all the way towards the front of the analyzer when it's reassembled. This will ensure that the tube is assembled with the forward end against the stop inside the detector manifold. A lot of words, but basically you're going to put the tube in, like I said. Once you get it in both sides, slide it gently toward the detector manifold till you feel it hit that stop in there. It'll stop. It won't go any further. And that's what they're saying in this. Just put the tube in, slide it all the way toward the detector manifold gently until you feel it hit that stop, and then retighten the screws on the retainers. After you've tightened the screws on the retainers, go ahead and reinstall the thermistor with its clip on the tube. Then reinstall the photometer cover. The manual talks about doing a leak check. After this procedure, they say automated leak test, but in most of the analyzers that I've worked with, it doesn't have the automatic leak test in it. But there's a leak test procedure in the manual. You can turn to that section of the manual and read through it. Essentially, what you do is you plug the sample port, you turn the analyzer on, and you observe the flow and the pressure on the test menu screens on the front of the analyzer. So there's a plug, the sample port, as you see in the image here. There's a plug fitting, or sometimes it's called a cap nut. It looks like a regular Teflon 1/4-inch tubing nut, but it's plugged. It shows a hole on the outside, but inside here it's plugged. There is no hole coming through there. And it's basically just going to provide a good seal so that air can't get in. So we've provided a seal on the sample inlet. So if air is going to get in here and cause flow, it's leaking in from somewhere. You broke the seal on those O-rings on the photometer when you pulled that seal out, that tube out. You broke that seal, so we need to make sure we have a good seal going on forward. We don't want to leak. So basically you're looking for, according to the manual, sample flow. You just hit that test buttons until you see sample flow. And you can see the test buttons on the lower left side of the screen there. You just scroll through those one way or the other until you see sample flow. Sample flow must be below 10 cc's per minute during a leak check. So a sample flow of 1, like you see on this screen, is pretty good. We've got a pretty tight system, and we're good with that. So again, if we see flow there, flow's not coming through the sample port, so it's leaking in from somewhere inside of the analyzer. And the second thing you look at, using the test menu buttons again, you go to pressure. And what you're looking for in pressure is something below 10 inches of mercury, 10 inches Hg, 10 inches of mercury. In this image, we're seeing 5.4 inches of mercury, which is an acceptable number. What we're doing here is this is also a pump check to check how strong your pump is. If you're getting above 10 inches of mercury and you don't have a leak, there's a pretty good chance that your pump is going to need rebuilt or replaced, or there's some other issue going on. So this is essentially a pump check, as you know, that you're doing just by looking at a number on the screen at the test menu when you're doing a leak check. So when you look at the 400e maintenance schedule in the manual, you see the absorption tube highlighted in red here, and it says annually or as needed, inspect and clean. And then notice the next column there, the cal check required. It says yes. So usually what we'll do after we do cleaning on the inside, replacing tubing in the inside of the analyzer or anything like that, is we'll condition it with ozone for a while before we check the calibration or calibrate it. So essentially, anytime you put something new in or clean something, it's a good idea, even if it doesn't specifically say it in the manual, to go ahead and condition it. And that's simply feeding an ozone calibration gas through it for some period of time, a higher concentration of ozone gas. And you can watch the concentration on the analyzer as you're doing this. And when it's conditioning something, you'll see the concentration just start to slowly increase. It'll get to a certain point below the cal gas concentration that you're feeding it, and it'll just start slowly increasing. And when it gets to where it's not slowly increasing anymore, you've conditioned it. Then you can check the calibration of it and go through your calibration procedures, which is a different video. This is just to show you the difference between some of the different analyzers that are out there. This is a Thermo version of an ozone analyzer, their 49i model. And in this one, they use 2 photometer cells. So on the left-hand side of those, you see those 2 silverish-looking tubes going across. On the left-hand side, there's 1 lamp, and there's a mirror that diverts that light through each of those cells. And then there are 2 detectors on the right-hand side. So each cell has its own detector, but 1 light source coming through. They're a little bit different, perhaps a little easier to get this out, but there are 2. In the next slides, I'll show you the inside of the tubes, and you'll see this Teflon coating inside of there. But the procedures are essentially the same. You're going to clean that out and put them back in. So here you can see the different tubes. There's a nut. The O-rings are in a different configuration. I've never had one of these seize and cause the kinds of issues that I see with the API in getting the tube out. But anyway, there are 2 tubes, and you can see if you look at the close-up on the lower right, you can see a kind of a Teflon coating inside of that tube. So it's a metal tube rather than glass, and then there's Teflon inside. So again, the procedures are essentially the same. You're going to go through with some plugs and clean those out and put them back in and condition them and do a leak check. But this is just to show you different procedures, a different kind of analyzer. It's a very similar procedure for doing this, and the manual describes the procedure.